Let's look at example 5. Let R be the region bounded from above by this graph, rad x, and below by this graph, 1 over x, over the interval from 1 to 4. Find the volume of the solid revolution rotate about the y-axis. So in this particular case, function is going to look something like this. I think I drew that too high, but got the whole page to do it, so it's no worry. There's 1, 2, 3, 4. There's, that's not even. Oh well. There's 1. There's 2. I want to graph my 2 functions here. So one function is rad x. So we got 0, 0, we got 1, 1, we got 4, 2. That's the square root function, right? So it looks like this. This is y equal to rad x. I want to graph this reciprocal function. This is 1 over x. So we know that it's going to have a vertical asymptote at 0 because the denominator here is equal to 0. I scribed this one in green. We also know that 1 over 1 is 1, 1 over 2 is 1/2, 1 over 3 is 1/3, 1 over 4 is 1/4. So this guy kind of comes like this. Like that. And this is y equal to 1 over x. What are you asking for, Armin? I don't follow what you want. I'll just post the, I post all the notes to Canvas. Any questions? We're rotating around the y-axis like this. Chop up parallel to the axis of rotation. So it looks like this. dx or dy, folks, what do you think? dx is correct. What's the smallest x could be? Smallest x could be is 1. What's the biggest x could be? Biggest x could be is 4. It's going to be 2 pi times the radius times the height. Now, we didn't shift this axis of rotation. So to me, it looks like if we took a typical shell over here, the distance from here to here is just going to be x. So I think the radius should be x. What's interesting this time is the height of the function, the height of this shell. So what do you guys think the height should be? Any thoughts? Good. Excellent. Excellent. Rad x minus 1 over x. Perfect. I just wanted to point out that this is like a harder version of the area between two curves. You just take the big function minus the small function. So if I asked you to find the area between the two curves from 1 to 4, you would just take the bigger function minus the smaller function and subtract them. And you would have to see what the region of integration would be. In this case, we give it to be from 1 to 4. Reagan asks, why is the radius not x plus 1? Because my x values are ranging from 1 to 4, but my axis of rotation is just the y-axis. If I had my axis of rotation over here, Reagan, then it would be x plus 1. If I had it over here, then it would be x plus 2. But when we don't move the axis of rotation, the radius is just going to be x. Does that make sense? Okay. Okay, so we write our integral. We can factor out to 2 pi, distribute. Remember on that antiderivative standard, I had asked you to integrate stuff that looks like this over here. I mean, it's in preparation for these types of problems. Some of us still don't really distribute. We make up some crazy fake product rule, but you gotta distribute. Makes sense. So as Luis says, this part becomes 1. So it becomes 2 pi, integral from 1 to 4, x to the 3 halves, minus 1 dx. Got to find the antiderivative. X to the 5 halves times 2/5 minus x from 1 to 4. And that's going to give you a 2 pi 2/5 times square root of 4 is 2. 2 to the 5th is 32. So that's 32 minus 4. Oops. Put parentheses around that whole thing. And then what do we get when we plug in a 1? We're going to get, well, 2/5, because 1 to any power is 1 minus 1. Units cubed. All right, great. So did anyone have any questions about this?